We discuss how can we convert a boundary condition problem into a Fredholm integral equation. Now we consider a particular case to discuss it, and all the problems means all the boundary problems can be converted into a Fredholm integral equation in this technique. Now we choose the problem like this: y double dash minus x y dash plus y is equal to 6x. Here instead of this minus x you can choose any function of x. Here plus y, instead of this you can choose any function of x into y. This is a linear differential equation, and the conditions we give the equation number 1, and the conditions are, suppose we choose y0 is equal to a, y0 is equal to a and y1 is equal to b. Now this boundary conditions a and b. You may consider any other function, for that is for 0, 1, any 2, any constant we need to follow this technique. Now first of all we need to indicate this equation number 1 from the limit x to 0, 0 to x. Now in general we consider the lower limit is the lower bound of this conditions on the differential equations. So integrating from 0 to x we get y dash x minus y dash 0 minus x, that is 0 to x not here, x we will face a confusion. To avoid this x we write here t, yt dt minus plus 0 to x yt dt, and this is equal to the integration of 6x is equal to, it is the x square, so ultimately 3x square. So all we can write here y dash x, and this value we now just skip at right side. I change it, we put it in right side. So ultimately I am here not x, here y dash b, and using by parts we need to solve it, and we simplify it, and after simplification we write it. You can write here x yx plus 2 0 to x yt dt. This is equal to ultimately 3x square, and write f dash y dash 0 here we write it, this is plus c, where c is equal to y dash 0. Now again indicating this differential equation with respect to x from the limit 0 to x we get yx minus y0. Now y0 is given a, so we now write here a minus this value 0 to x t yt plus 2 into 0 to x, and we know that the indication of this function is x minus t cos y minus t, plus the indication of this function is x cube plus cx. So simplifying we get yx is equal to a plus cx plus x cube minus 2x minus 3t yt dt. So we have used one condition, y0 is equal to a, but we need to use another condition, y1 is equal to b. So now we put this value. So now y1 is equal to b gives y1 is equal to b. Here if we put y1 is will be, then left side will be b and right side will be a plus c plus 1 minus 0 to 1 2 minus 3t yt dt. So we are interested to find the value of c. So ultimately, finally we get the value of c as, we write here, c is equal to b minus a minus 1 plus 0 to 1 2 minus 3t yt dt. Now if we put, now we give the equation number where I get yx, we put that equation as 3. Now we put the value of c in this equation and we get the desired integral equation. So putting this value of c, we get yx is equal to a plus b minus a minus 1 into x plus x cube plus 0 to 1 x into 0 to 1 2 minus 3t yt dt minus 0 to x 2x minus 3t yt dt. So ultimately we get a minus b minus 1 into x plus x cube. Here this limit is from 0 to 1. Now we make it two branch, one from 0 to x and another from x to 1. So for x to 1 we write here x to 1 we can write, and now we write x inside of integration, so we write 2x minus 3xp into yt dt, and 0 to x and after simplification we write here plus 0 to x 3t minus 3xp yt dt. So our desired integral equation is yx is equal to a minus b minus a plus b plus b minus a minus 1 into x plus x cube plus 0 to 1 k xp yt dt where kxp is equal to 2x minus 3xt if x less than t less equal to 1 and 3t minus 3xt if 0 less equal to t less equal to x. So I finish.